First thing, just a little definition. A matrix is just an array of numbers. So you will see something that looks like this. Okay, it has rows, it has columns, we have these brackets around the outside. And it can be used in a lot of different instances. Anytime you have a lot of data, a matrix is very helpful for keeping it organized. You see it in computer science. If you go into coding, it shows up a lot there. It can be all used for equations as well, and that's a special type of matrix called an augmented matrix. So in general, a matrix is just any array of numbers. With an augmented matrix, we can take it and use it for a system of equations. So for instance, if I said system was 3x minus 5y equals 8, and negative x plus 4 equals 13. The matrix is just those coefficients. So you might see a question on HT that gives you a matrix and asks you what the equation is. If you know the notation, it's not very hard. We basically put the x coefficient, the y coefficient, there is a vertical bar representing the equal to, and the constant. So my x, my y equals my constant. So that's augmented. That vertical line is representing the equal sign. And everything in the first column is an x value. Everything in the second column is a y value. And it's equal to our constant. What do you think you would put in if there was no x in our problem? A 0. Oh, yeah. So if I added in like another equation, negative 2y equals 6, then all that would do is add one more row to my system. There is no x, the y is negative 2 equals 6. So we can have as many rows as we want. Each row represents an equation. I'm not going to do a whole lot with that part today, but I thought it might be helpful to at least see it, just so you can understand the difference. Today I just want to talk about some operations with them. Adding, subtracting, multiplying with matrices. In general, when we're talking about matrices, we do need to know the size of a matrix. And size is always written rows by columns. So this first matrix, how many rows did I have? 2. How many columns? 3 total. Each vertical line is column, so 1, 2, 3. So that one is a 2 by 3 matrix. 2 rows, 3 columns. This one, what would be my size of this matrix? 3 by 3. 3 rows, 3 columns. Rows are horizontal, columns are vertical. Put the size of the matrix. Rows by columns. Okay, if I want to be able to add or subtract with matrices, they have to be the same size. Okay, if we're going to put them together, you add or subtract the corresponding entries, so they have to have the same size with them. So let's go to, I'm gonna skip some of this. Okay, let's do this one. I want to find the sum and difference of these matrices. What's the size of matrix A? 2 rows and 4 columns. Matrix B, 2 by 4, 2 rows, 4 columns. So we can add them. So the sum, matrix A plus matrix B. When you add matrices, you are going to get a matrix. It'll be the same answer. I'm going to have a 2 by 4 matrix. 2 rows, 4 columns. And what you think intuitively is probably correct. If I told you to add these, if this were a question on the ACT and you'd never seen it before, what would you do? We're basically just going to add corresponding numbers. So, number in row 1, column 1. What's this one? So 2 plus -3. -1. We're just going to work through adding corresponding numbers. 4 plus 4. 8 plus 0. -3 plus 1. Okay, then we do the second row. 0 plus 6. 1 plus 8. 2 plus 2. And 3 plus 0 is 3. So nothing fancy there. Adding, we just add corresponding numbers. Same is true with subtraction. So I asked you for A minus B. Okay, so what's 2 minus -3? Becomes 2 plus 3, which is 5. 4 minus 4. 8 minus 0. -3 minus 1. Second row, 0 minus 6. 1 minus 8. 2 minus 2. And 3 minus 0. Okay, if I said matrix C was this, could you add that to matrix A? No, because I don't have all the same corresponding numbers to add. In that case, you would just say no solution. So in order to be able to add or subtract, they have to match up, have the same number of entries. Is that part okay? Let's look at this problem. We're going to do a couple different operations here. So I'm putting 3 matrices up here. The first thing I asked for is 4A. What do you think that means? It's actually not just the top row. Yeah, it's taking every single entry in that matrix times 4. So think of it as distributing a 4 to everything. So what would the first row become?
4, 20.
And the second row? So we can multiply by a number. You just take every entry times that. So B 1/3 C says take every number in matrix C times 1/3. So 9 times 1/3. 0 times 1/3. -3 times 1/3. And 6 times 1/3. It is okay to have a fraction for an entry, so if we got like 2/3 or something as a number in the matrix, that's not a big deal. That can happen. C, I'm asking you to do 3A minus 2B. So you might be able to just write that out. I'm going to show my work since we are just learning this. 3A means I do what? Okay, everything in A times 3. So we get 9, 3, 15, 15, -2, Then I take everything in B times 2. 8, 2, 0, 16, 2, -6. And then what? Subtract the corresponding entries. So 9 minus 8. 3 minus 2. 15 minus 0. -6 minus 16. 0 minus 2. 18 minus -6. So that becomes 18 plus 6 or 24. Alright, so adding, subtracting, and what's called scalar multiplication, just multiplying by a number. It's 100% what you would expect. If you just had to blindly guess, you'd probably get there. Okay, you're just putting corresponding numbers together. The difference comes in multiplying matrices together. So that's the second part I want to talk about. Are there questions in what I've done so far? When you multiply matrices, what you end up doing is taking a row times a column. So to multiply a row and a column, so row is horizontal and a column is vertical. When you multiply a row and column together, you get a single number for your answer. To do it, we multiply corresponding entries and then add them. So we are going to take the first number in the row times the first number in the column, and that will give me a 9. Then I take the second number in my row times the second number in my column, so -5 times 4. Then I take the third number in my row times the third number in my column, that gives me -10. I add all of those together, so -21 is the answer to the row times the column.
There's multiple columns.
Next slide. Step ahead. So when we multiply matrices, a lot of times matrices have multiple rows and multiple columns, right? So we are going to have to go through piece by piece. It will only work if the number of columns in the first has to equal the number of rows in the second. Right, so I would write down this blurb up here. In order to multiply them, the number of columns in the first has to equal the number of rows in the second. So I could decide that just by looking at the sizes. So if I said a 2 by 3 matrix and a 3 by 4 matrix, the number of columns in the first has to equal the number of rows in the second. So can we multiply those? Yes. The columns in the first and the rows in the second are the same. So it means we can multiply them. These numbers out here will give us the size of the answer. So the answer, the final matrix is going to be a 2 by 4 matrix. So when I multiply a 2 by 3 and a 3 by 4, I create a matrix that has 2 rows and 4 columns. Now, this kind of goes against everything you're used to. But what if I switch the order? Can I take a 3 by 4 matrix times a 2 by 3 matrix? No, because the columns in the first and the rows in the second are not the same. So unlike other multiplication, when you're multiplying matrices, order matters. It is not commutative. It's not the same both directions. Alright, so we are just going to practice multiplication until we have the hang of it. And we'll just work through examples. The first thing we're going to do is check to see if we can multiply them, decide how big our answer should be, and then we will find that matrix. So we are going to do A times B. Second to write it down. First, let's make sure we can multiply. We don't want to put all the work in if it's not something that can be multiplied anyway. So if I'm looking at this, what is the size of the first matrix? What's the size of the second one? Oh, well, I picked a bad example. I did it exactly when we did. Huh. My last slide, I wrote this down as a scenario. Can we multiply them? Yes. How big is my answer going to be? 2 by 4. So I'm going to make a matrix where I'm going to show my work for a second. But this one will have 2 rows and 4 columns. Okay, so this number is in row 1, column 1, right? So I'm going to take the first row times the first column. So to multiply a row and a column, you multiply the corresponding numbers and add them together. So 2 times 2, 4 times 4, and -1 times -3 is 3. So I'm writing out my work now. Some people don't like to show as much. That's up to you. On test or quiz, it's helpful if I can kind of see where your answer is coming from. So altogether, that entry becomes a what? 23. Okay, I am still in the first row of my matrix. So I'm still taking this first row, but we are just going to move to the second column. So then I do 2 times 5, 4 times 8, and -1 times 1. Add those together and we get 41. Okay, I'm still in the first row, so I'm still multiplying the first row, but I'm just moving to the next column. So 2 times 1, 4 times 0, and -1 times -2. Add those together, get 4. Still in the first row, I'm just doing the final column. So 2 times 4, 4 times 6, and -1 times -1 is 1. So that gives me 33. Okay, I have just finished the first row in my matrix, so I am done with row 1. Now I'm going to take row 2 times each of these columns. So 5 times 2 is 10, 8 times 4 is 32, 0 times -3 is 0. We're getting 3. Do you guys see where I'm getting my numbers from? So now I'm in second row, second column. So first row 2 times column 2. So 5 times 5 is 25. 8 times 8, 64. 0 times 1 is 0. We get 89. Moving to the third column. So 5 times 1 is 5. 8 times 0 is 0. 0 times negative 2 is 0. And we just get a 5. And the last one, 5 times 4 is 20. 6 times 8 is 48. 0 times negative 1 is 0. And we get 68. What questions do you guys have for me there? Let's try a couple more and make sure we've got this. So first we need to see if we can multiply them. What's the size of the first one? The second one? So can we multiply? Yes. How big will our answer be? 2 by 4. So same size as our last one. So we start with the first row and we'll take it times each of our columns. 2 times 2 is 4. Negative 2 times 3. Negative 6. 4 plus negative 6 is negative 2. And move down the columns. So 2 times 1 is 2. Negative 2 times negative 1 is 2. 2 plus 2 is 4. Next one. 2 times 4 is 8. Negative 2 times 3. Negative 6. Add those and we get 2. Next one. 2 times 6 is 12. Negative 2 times 2 is negative 4. 12 plus negative 4 is negative 8. So the first row is complete. Yeah. So now first row is complete. We go to our second row. So 1 times 2 is 2. 0 times 3 is 0, and we get 2. Next column, 1 times 1 is 1. 0 times negative 1 is 0, and we get 1. One times 4 is 4. 0 times 3 is 0, and we get 4. And final one. 1 times 6 is 6. 0 times 2 is 0, and we get 6. Can you guys do one? Okay. Here is your problem. So how big is the first matrix? And the second one? So we can multiply because those threes are the same. The outside tells us our size. So it's 2 by 2. So we take row 1 times column 1. So that's 1 plus negative 2 plus 6. Then we take row 1 times column 2. So 1 times 2 is 2, 0 times 2 is 0, 3 times 4 is 12. That gives us a 14. Okay, now we move to the second row. Second row, first column. So 0 times 1 is 0, negative 1 times negative 1 is 1, 4 times 2 is 8, and that gives us a 9. Then second row, second column, so 0 times 2 is 0, negative 1 times 0 is 0, 4 times 4 is 16, and we get 16. So 5, 14, 9, and 16. Alright, we did pretty well with that one. Not perfect, but we're doing pretty well. Let's try, I'm going to make up a problem. What's the size of the first one? Second one? So can I multiply them? Yes. How big will my answer be? So 2 rows, only 1 column for our answer. Right. So I take my row times my column. So negative 6 times 5, 8 times 1. And then we do the second row times that column. So 3 times 5, 4 times 1, and we get 19. What if I flipped it and said, I want you to take so the exact same matrices, but I flipped the order. What's the size of the first one? And this one? These numbers don't match, so we cannot multiply them. There is no solution. Alright. There is a handout posted on Google Classroom. So you have to do it on your notebook, and you have the rest of the hour to work on that and ask questions. It's not very long.